Hello, this video is on section 7.6, which is exponential functions, and learning target is to evaluate and graph exponential functions. So the only definition for this video is exactly what an exponential function means. Now, an exponential function is in the form of y equals a times b raised to the x power, so your exponent in this example is the x. It's the variable that we don't know. It's the one that maps all of the horizontal points on the x-axis. Some restrictions on what a and b can equal. A is not allowed to be 0, and b has to be positive or greater than 0, but it can't equal 1. The reason why b cannot equal 1 is 1 raised to any number is always going to equal 1. So there's really no point on having an exponentially increasing or decreasing graph if all the points are just going to equal 1. Okay? Now, I'm trying to get a little bit of feel for what you guys know as a growth and decay before we go into the next section. An example of what an exponential function look like is the general form. Let's say if we have y equals just 2 raised to the x power, there's no a term, it's just your base of 2 raised to the exponent of x. The exponential function is gonna cross your y-axis or your y-intercept at the point 0, 1, because anytime your x value is 0, that's automatically going to give you a 1. Now, this isn't always the case. Sometimes you may have some numbers being added to the end, subtracted, multiplied. You'll see more of that in the shifts in AG3, but just for right now, when looking at this example, so it's staying positive and it goes through the point 0, 1, and then it starts increasing, and as it's going farther to the right, it's increasing at a sharper angle. So it's not just increasing at a steady rate, it's increasing exponentially all the way up. Another example is if you have a decay. Let's say it was a negative 2 to the x. It's going to be the exact same thing, but just flipped down to the other side. So it's still, as it's moving right, it's just decreasing down, and your y-intercept is the point 0, negative 1, because whenever this point is 0, that's going to equal negative 1. No matter what this is, you put the negative out in front, and it's going to equal negative 1. Alright, so we'll go through some more examples about what the functions look like, some different things you could do to them, and how to solve. More importantly, it's going to be a very word problem heavy section where we're trying to look at how to fit some criteria into these variables on some of the exponential functions, and then how to solve for one when given one of the variables. Alright, thank you.